When we talk about air quality, it's important that we can quantify the amount of pollutants in the air. In order to do that, we need to understand the units used. For example, we might say, keep the concentration of CO2 below 1,000 ppm, or the EPA defines good air quality as below 9 micrograms per cubic meter of particulate matter. But what do these mean? Remember that we typically think about air pollution in terms of gases and particles. Let's start with gases. Consider a box full of air that's 1 meter by 1 meter by 1 meter. That's about 3 feet per side. How many air molecules do you think are inside? 1 million? A billion? Actually, there are more than 1 million billion air molecules inside that 1 cubic meter box. More specifically, there are about 10 to the power of 25 air molecules. That's a 1 with 25 zeros after it. These numbers are unfathomably large. There are more air molecules in a 1-inch size cube than there are grains of sand in the entire world. So how do we talk about pollution when there are that many molecules? Well, we use a ratio. Imagine taking a sample of 1 million molecules of air. Almost all of them would be the gas molecule nitrogen and oxygen, which are the majority of what makes up air. Gas pollutants are actually only a very, very small number of the overall air molecules. Let's use carbon dioxide as an example. In outdoor air, if we counted out 1 million air molecules, only about 425 of them would be carbon dioxide. That's 0.0425%. Not a very helpful way to talk about their amount. So instead, we use a ratio, or a concentration, in terms of 1 million. If there are 425 molecules of carbon dioxide in 1 million molecules of air, we say that we have 425 parts per million, or 425 ppm of carbon dioxide. For other pollutant gases, the amounts are often lower. For example, NIOSH, the National Institute for Occupational Safety and Health, sets a recommended exposure limit for carbon monoxide of 35 parts per million over an 8-hour period. That is, if you sampled 1 million molecules of air, less than 35 of those million molecules should be carbon monoxide. The amount of some pollutants can be small enough that we need to think about them in terms of 1 billion molecules of air. This ratio works the same way, but now imagine needing to sample 1 billion molecules of air, and there's 1 molecule of a gas pollutant in that sample of 1 billion. We say we have 1 part per billion, or 1 ppb. Unfortunately, even at these very low concentrations, many pollutant gases can still negatively impact our health and the environment. So what about particles in the air? Particles are hundreds of times bigger in size than air molecules and can weigh millions of times more, but their numbers are usually much lower. If we wanted to compare the number of particles with the number of air molecules, we'd have to count out about 1 quadrillion air molecules. That's a 1 with 15 zeros before we found 1 particle in the air. Yet, like pollutant gases, particles, even at these very low concentrations, can have negative health effects. Particle concentrations are generally characterized in 2 ways that are different from how we characterize gases. The first is just the total count of the number of particles that are floating in some volume of air. Let's again consider a 1 meter by 1 meter by 1 meter box of air. It's our volume of air. In a really clean environment, we might have about 1 million particles or 100 million particles in that box. That's our total count. For total count of particles per volume of air, we'd say we have a number concentration that's 100 million particles per meter cubed. Well, that sounds like a lot. Remember that there are 1 million billion air molecules in that same box. In a dirtier environment, the particle number concentration might be 10 or 100 times higher, and in a really dirty environment, such as you might encounter in a wildfire smoke event, it might even be 1,000 times higher. So that's one method for measuring particles, a total count per volume. We can also think about weighing those particles. If we could take those 100 million particles from our relatively clean meter cube of air and put them on a scale, how much would they weigh? The answer is not very much. Probably less than 1 microgram in that entire cubic meter. That's 1 millionth of a gram. And for reference, some other things that weigh about 1 gram are a paperclip, a dollar bill, or a raisin. So the weight of all those particles added together is around 1 million times smaller than the weight of a dollar bill. In a somewhat dirty environment, the mass concentration might be like 10 to 20 micrograms per cubic meter. And in a really dirty environment, you can have hundreds of micrograms per cubic meter. You might have encountered this outside during periods of wildfire smoke, or inside if you've ever burned something while cooking and not had your exhaust vent on. For reference, the US EPA recently revised their primary annual PM2.5 standard for outdoor concentrations down from 12 micrograms per cubic meter to just 9 micrograms per cubic meter. Now, particles can vary greatly in size, typically depending on their source. There are usually a lot more small particles than big ones, but the bigger ones weigh a lot more. So our counting method might show that the number concentration is much higher for the really small particles, while our weight method might show that the mass concentration is higher for the bigger particles. Both measurement methods are useful, and you'll want to keep them in mind as we talk about pollution amounts throughout the modules.